Question is, a vehicle with horn of frequency n is moving with the velocity 30 meter per second in a direction perpendicular to the straight line joining the observer and the vehicle. This is the vehicle which has the horn, so it acts as a source, and a line joining the observer O. This source is moving perpendicular to this line with velocity 30 meter per second. So angle between this line and the source is 90 degree. The observer perceives that sound to have a frequency of n plus n1. Then what is n1? Given the speed of the sound is 300 meter per second. So direction of the speed of sound is v, that is equal to 300 meter per second. Here observer is stationary and source is moving. Therefore we will have the formula nu dash equal to nu v minus vo by v minus vs. This is 0. So, and nu dash is given n plus n1, and original frequency is given n into v by v minus, and the velocity of source. This source is moving with velocity 30 meter per second perpendicular to the line joining the source and observer. So in the direction of the line, this velocity will be 30 cos 90 degree. So replacing it with 30 cos 90 degree. We know cos 90 is 0, so 30 cos 90 will be 0. This implies that n plus n1 will be equal to n into v by v. This v and v get cancelled by 1. So we have n plus n1 equal to n, or n1 equal to 0. This is the answer. Third question is, two stationary sources each emitting wave of wavelength lambda. An observer moves from one source to another with velocity u, the number of the beat heard by him. There are two sources S1 and S2, and both are stationary, and in between them one is the observer, which moves from one source to another with velocity u. The wavelength of the sound emitted by the source S1 and S2 are lambda, and the speed of the sound from the S1 toward the observer is shown. This is suppose v. Similarly, speed of the sound from the S2 is also v. Now using the apparent frequency formula for the first case, that is from source 1, it will be equal to frequency of the source into velocity of sound minus velocity of observer, which is u, and it is also in the direction of the velocity of sound. Therefore it is v minus u divided by v minus, and observe is the source S1 is stationary, so it is written 0. Therefore we will have nu into v minus u by v. This is the equation number 1. In second case, when source S2 is emitting the sound, the apparent frequency heard by the observer will be nu 2 dash, that is equal to frequency of the source into v minus. Now the source is moving in opposite to the direction of the sound, so we will take it negative, so it is minus u divided by v minus 0, because S2 is also stationary. Therefore v nu 2 dash will be equal to nu into v plus u by v. This is the equation number 2. Therefore the beat frequency will be equal to nu 2 dash minus nu 1 dash. It will be equal to nu v plus u by v minus nu into v minus u by v. It can be written as nu by u v, and remaining is v plus u, and then minus v plus u. V and v get cancelled, so we will have nu by v into 2u. And because v is the velocity of sound, and it is equal to nu into lambda. Lambda is given, therefore we can write the frequency, velocity by frequency is equal to lambda, or it can be written as 2u by lambda. This is the answer. Next question is, a train is moving at a speed of 220 meter per second towards a stationary object. Emit a sound of frequency 1000 Hz. This is the train, which is moving at a speed of 220 meter per second towards an object, and the emitted sound has a frequency 1000 Hz. This sound, when reaching the object, reflects back and returns towards the train. Some of the sound reaching the object get reflected back to the train as echo. The frequency of the echo as detected by the driver. Driver is with the train. So effectively this driver is acting as a observer. And this reflected sound is the source. That means effectively the reflection, say train is moving towards the left side, emitting the sound of velocity v and frequency 1000 Hz. So we can convert this case as the observer is moving with velocity 220 meter per second. This is the velocity of observer, and the source is moving towards left side with the speed of 220 meter per second, and sound moves from source to observer with the speed of 330 meter per second. Frequency of the sound is 1000 Hz. Now we have to find the frequency heard by the observer. From the Doppler effect formula, nu dash is nu into V minus Vo by V minus Vs. So apparent frequency nu dash will be equal to the original frequency 1000. Velocity of sound, this is 330 minus. Now our reference direction is from source to observer. Therefore velocity of observer is opposite to this reference velocity direction. Therefore we will take it as minus 220 divided by 330 minus, and velocity of source is in direction of velocity of sound, so it is taken positive, it is 220. Therefore we will have 1000 into 550 by, it is 110, on cancelling we will have 5, that is the apparent frequency will be equal to 5000 Hz. So in the case of the reflection, frequency of the apparent frequency of the source increases. Fifth question is, an observer moves towards a stationary source of sound with a speed 1/5 of the speed of sound. It is given that source S is stationary, so its velocity will be 0. The speed of the sound emitted from the source is V and is moving towards the observer. And observer is moving towards the source with the speed 1/5 of the sound, that is V by 5. This is the velocity of the observer. It is given that the wavelength lambda and frequency is f for the sound emitted by the source. So to find the apparent frequency, we use Doppler effect formula, that is nu dash is equal to nu V minus Vo by V minus Vs, and substituting the values here, we will have f dash apparent frequency equal to natural original frequency multiplied by velocity of sound is V minus velocity of observer. It will be minus because observer is moving opposite to the direction of the sound wave, so it is V by 5 divided by V minus 0 because source is stationary. So it will be equal to f into V plus V by 5 divided by V, or we can write it as 6V by 5 by V. This V and V get cancelled, so it is equal to 6 by 5 F, or that is equal to 1 by 2 F. This is the apparent frequency. And wavelength of sound will be lambda dash, that will be equal to lambda. It remains same, as wavelength does not change by the motion of the observer. Sixth question. A vessel in a circle with angular velocity omega equal to 20 radian per second using a string of length 50 centimeter. A string of length 50 centimeter to which a vessel is tied is revolving with angular velocity omega given as 20 radian per second. So its linear velocity will be along the tangential direction. If the frequency of the sound from the whistle is 385 Hertz, so natural frequency is 385 Hertz, then the minimum frequency heard by the observer, so we have to find the apparent frequency, and this frequency should be minimum by the observer which is far away from the center. So suppose this is the observer and this whistle act as a source. So velocity of observer is 0, and we have to use the formula nu dash is equal to, this is the Doppler effect formula, that is nu into V minus VO by V minus Vs. It is equal to nu, that is 385, into speed of sound is given 340 meter per second, so it is 340 minus observer is stationary, it is 0, divided by 340 minus. Now we have to find the case in which the apparent frequency becomes minimum. So Vs should be taken so that this minus become plus and magnitude of Vs become maximum. To this, there are the two cases, one is A and another is B. In case of B, the speed of the rotation will be equal to, that means it is the speed of source, this is equal to omega r. This is the linear velocity related with the angular velocity. Omega is given 20 radian per second and radius is given 50 centimeter, that is 0.5 meter. So effectively it is 10 meter per second. So velocity of source is 10 meter per second, and for minimum apparent frequency, the direction of the velocity of source should be opposite to the direction of sound, which is taken from source to observer. Therefore, for point B, we will have minimum apparent frequency and the magnitude is 10 meter per second with negative sign, because direction of Vs is opposite to the V. Therefore, we will have 385 into 340 by 350. This 0 and 0 get cancelled. This is equal to 385 into 34 by 35. Cancelling by 5, it will be 7 and it will be 77. Further on, cancelling by 7, we will have 11. So this is equal to 11 into 34, and this will give 374 Hertz. This is the answer.